All right. So here's an example of a module and how you would flowchart it. Except we're going to use vertical bars on the function calls rather than the horizontal bar. On the other hand, since this slide shows you a horizontal bar, I'm not going to often use it. But in all the class examples, we'll use the vertical bars. I just didn't copy and paste vertical bars on top of this illustration. So what this does, well, let's just follow it. Declare our string name and our numeric balance. This is a little bit more than what we've been doing in our flowcharts. We haven't been doing declarations. Declarations are when you define a variable before you use it. Input, name, balance. This is showing inputting two things in one block. Okay, I'd rather you put two separate things, just as a reminder to yourself that when you're writing, okay, that's two different chunks of code I'm going to have to write. That's okay. And then display address info. Now this is a function call, kind of like our call to the flower function or to the goto function, which means it runs off and it does some separate code. Notice that this one doesn't have a start and a stop. It has a name of a function. What does this function do? It displays ABC manufacturing. It writes out the address. It writes out the rest of the address in Wisconsin, and it returns. So apparently this is the address of our company, and it's hard-coded into the program. If we ever move, we're in trouble and have to hire the programmer to fix it. Now that we've displayed the address, we're going to display the customer name. And then we're going to display the balance. This is a somewhat silly program, but it's okay. You see what it's doing. There's some variable declarations up here which set things up. Then it asks for some information. Then it calls a function, which runs over here, comes back, and then we do kind of the wrap up. We do some outputs over here. I hope so.
Yeah, so
Yep. Good deal. So here's a Python version of it, I believe, or is it just pseudocode? That's pseudocode. How do I know? Because Python doesn't have a start command and a stop command. So, declarations. We declare our two variables. We haven't been doing that. Maybe I'll start making us do it. We'll see. Input, name, and balance. Declarations are not as important in Python because you don't have to declare your variables before you use them. And just about every other language that's not a scripting language, like C++, Java, C#, you have to declare your variables first before you can use them. Then input, name, and balance. Then call the display address function. Output, after we display our address, the customer's name and the balance. And then stop. But display address info, you can tell by the parentheses, is its own function. So down here, display address info, it prints out three things, and then it returns. So the flow of control is, I'm going to do that line, I'm going to do these two lines, and oh, that's a function call. I better run down here. Do these three lines, then return back to where I was so I can do the last things up here. Kind of like we did on the flow chart. It ran up there, then it came back, and it did the last two. Kind of like hiring a servant to do your work for you. He runs off, he does all that stuff, you sit there and wait, and he comes back. I am so sorry.
Is Unix in the same group?
Unix isn't a programming language. It's an operating system like Windows or Mac OS. So you can run C++ programs or Python or any other number. Yeah, and I'm sorry I ignored you. I apologize for that. So programmers say that the statements contained in the module have been encapsulated. Well, that means capsule, you're putting something inside something. When you modularize a program, both programs behave exactly the same as they did before you modularize it. What probably happened is the programmer took these three lines of code, cut them out of the program, pasted them into the module here. It was probably just one long program before that was done. And then the programmer decided, I could display the address over and over, so I'm going to cut those three lines out and put them in their own module. That's called encapsulating it. So when you modularize a program, both tasks Both programs work the same way. However, you might like the modularized program for two reasons at least. For one thing, the main program is shorter, and it may be easier to follow because it contains just one statement to call the module. Just like in our flower function. It only took one function call for it to go and run those 8 lines of code that drew all the circles to make the flower, rather than all the output statements to make it do it. Secondly, it's easy to reuse. If we want to draw that flower in another program, we can just copy and paste that module in it. Or we could even issue an import statement and import the code from that module into our new program. We don't even have to type it in again or copy and paste. So once we create the address information module, we can use it in any application that needs to print the company's name and address. So we do the work once, and then we can reap the benefits many times. So determining when to modularize a program does not depend on a fixed set of rules. It requires experience and insight. Programmers do follow some guidelines on how to break them up, and some companies have arbitrary rules. Like a module should not have more than a page worth of code in it. If it has more than a page worth of code, break it up into other modules. Or a module should never have more than 30 statements in it. Or whatever. Those are arbitrary. And your company would tell you if you were supposed to follow that. Never have a module with only one statement. Well, if it only had one statement, why would you modularize it, you know? Okay. Those are not our rules. Those are just example company rules, but you could kind of follow them. We're not going to really write very many programs that would be long enough to warrant worrying about the page length of code problem. How can you tell what's the page anyways when you're editing on screen? You can place any statements within modules that you can put in your primary program, in your main body. You could have input, processing, output statements. You can call other modules. You can define variables. So here's an example. Isn't that just the same example? Of, not quite. The difference between this one and the one before, back up, is that this one was coded in such a way that the output statements had these constants in it, literals. That was typed literally into the program. ABC Manufacturing, 47 Park Lane, Omro, Wisconsin. If the programmer is going to change it, they have to go and edit these output statements. In this version of the flowchart, I have a blank page here I need to get rid of. Come on. Those variables were put, instead of outputting literals, they output variables. And then the variables were set to the values. So line 1 is company name. Line 2 is a street address. Line 3 is a state zip code. And then it says output line 1, output line 2, output line 3. Why would you do that? Well, later on, you may want to read these in from a file so that the user could change the address without changing the application itself. Or it's going to read it from somewhere, or it's going to be passed in from another module. So this is supposed to be demonstrating that you can declare variables in a module just as easily as you could declare variables and use them in your main code. And down here at the bottom is the pseudocode version of that. But the variables and the constants that you declare in that module are only usable inside that module. They are, quote, visible, or they are only in scope within that module. That means that the program only recognizes them there. If you try to get a hold of that data from outside of it, it can't load that data up. If for some reason down here I wanted to output line 3 right there, it can't. Line 3 is limited to this function. If you want to get line 3 out, you have to do something special. You can either return line 3 or you could declare line 3 as a global variable, which means that it exists for both modules. And you can't really flowchart that, but we'll talk about it anyways. Flowcharting was invented in the 40s and doesn't quite keep up with modern languages, but it's still a useful way to discuss logic. So the programs say that the variables and the constants are local to the module. These are local variables, line 1, line 2, and line 3. So they're declared in that module. They are not recognized and useful in the other modules that might be in that code. One of the motivations for creating modules is that separate modules are easily reusable in multiple programs. If display address info is useful for several programs within the organization, you could put that in its own file, and every program that needs to use it just does an import, or you could copy and paste it or whatever. It makes sense that the definition for its variables and constants could come with it. If you put just one copy of that file out there and every program needs to import it, just like we did import turtle, then the address could just be changed in one place. It makes the modules more portable, meaning that they are self-contained units. They're easily transported between program to program that's going to use it. All right, this is about the last slide. Besides local variables, which are the variables that are used within a module, you can create global variables. Global variables are known to the entire program. They are said to be declared at the program level. That means they are visible to and usable in all the modules called by the program. The opposite is not true. Variables and constants declared within a module are not usable elsewhere. Okay. Rather than have a page full of text, we're actually going to demonstrate that. So let's fire up idle. I thought there was another slide. Yeah, I think there is really. Just a blank page. Anyways, but we're not going to hit that for now. We need some practice as well as theory. So file new. Turtles are a great way to visualize all this stuff, so we're going to play with a turtle again. Import turtle. Turtle is the library that we're going to be using. It's got a whole bunch of modules in it that we get to take advantage of. Alright, what are the names of some of the other Ninja Turtles? I'm tired of Leonardo. Raphael. We're going to use Raph.
And Donatello.
Yeah, let's use Don for Donatello. Don is equal to turtle, all lowercase, dot, uppercase T turtle, and don't forget the parentheses at the end. Now Don is a variable. It's a complex variable that contains an entire turtle rather than just an integer or a float or a string, but it is a variable. We have defined it outside of any modules, meaning that this is actually a global variable. I'm going to put the word global out here. You don't have to, but I'm going to. And matter of fact, we're going to declare more than one global variable. How many sides does a square have? Square has 4 sides, so square sides equals 4. Triangle sides equals 3. We're declaring more global variables. I could have just added the comment global once on top of these declarations. And what are the angles for a square? Every time you turn, you have to turn how many degrees? 90. So a square angle is equal to 90. And a triangle is equal to 120. I'm getting real tired of typing global, so I'm just going to put a comment up here at the top that says global variables. And erase those. Now we want to draw, now we're going to write 2 modules. One called draw square and one called draw try. which draws a triangle. That's going to require two definition statements. DEF, draw square, and just because I know I'm going to need it later, I'm going to come and put another definition for draw triangle. I could call it draw tri or draw triangle. That's easier to type, so I'm leaving off the rest of the word. Alrighty, so to draw a square, we need some kind of loop. I could use a while loop, I could use a for loop. I think I'll use a while loop. Side is equal to 0. This is how many sides we've drawn. Now, while side is less than square sides, because that's how many sides we want to draw, send our turtle forward 100, and then he needs to make a right, I don't know why I like left turns, but let's do that. A left turn, t dot left, and his angle that he needs to go is called square angle. And then I need to add 1 to side so that we can keep track of how many sides we have drawn. Side plus equals 1. Now I'm done with the module, so I'm going to unindent. I unindent one level and I put return. Don't put return there, indented with everything, because then it would return after it did only one line. Backspace it so that it's underneath the while statement. And honestly speaking, you don't need a return statement, because as soon as it finds a totally unindented line, it considers that the return. But I'm going to put it there anyways, just to make it real clear. Alrighty, draw triangle is so similar to this one that I'm going to copy those 5 lines. I'll be right there. 6 lines. Copy them. Paste them, but I need to make 2 changes. Instead of square sides, that needs to be triangle sides. So I changed that one. You don't have to add the little red marks. And instead of square angle, this is going to be triangle. So I changed that line as well. And so this is a mistake. Our turtle is called Don. Here I use T everywhere. I could fix that by replacing every occurrence of T with the word Don. Or I could replace Don with T. I'm going to do that. Go up here and change Don is equal to turtle to just T is equal to turtle. You don't have to add the comment. Alright, I'm going to run it, but it's not going to do anything except create some variables and show a turtle screen. It's not going to draw anything. Why? Because all the drawing commands are encapsulated in these modules, and none of these modules are called, so it never happens. So I'm going to save it, and even though I didn't call it Don, I'm going to call it don.py anyways. We know who that masked turtle is. So don.py. I'm going to run it. The real reason I'm running is just to check the syntax. Okay, it popped open the window when it called that turtle command with the parentheses, but it didn't draw anything. Anybody have syntax errors that you need correcting at this point? Okay, just a sec.
I don't think I have one.
So it doesn't do anything. We're not drawing anything because although we've defined the functions, we're not invoking them. Invoking is a fancy word for calling. So down here, draw underscore square. Let's just do that. Let's leave that alone and then try running it. It drew a square. Let's call it again. draw underscore square. This is not going to be terribly exciting because it's going to draw the same exact square in the same exact place. Okay, that's kind of like a big whoopty. But what could we do to make this different? We could move the turtle between drawings. Let's make him turn right 90 degrees. T dot right 90 degrees. I put that between the two draw squares. Let's run that. Now we could kind of draw a window shape if we made him turn 2 more times and draw 2 more squares. I'm going to copy and paste. I copied these 2 lines, copied, paste, that's the 3rd square, paste, that's the 4th square. Alrighty. So we've seen that we encapsulated all this code that we otherwise would have to be doing right there. Here's what it would look like if we didn't have that code. Now don't do this change. But I would have to do that, and I would have to unindent it. I would have to do that, I would have to do that, and I would have to do that if it was not modularized. Anytime you find yourself cutting and pasting multiple lines of code, that's about time that you need to modularize it. So I'm going to undo all that. Let's use the triangle the same way. I'm going to put a space there. Draw underscore try. You know, if we did this right, we could probably make a triforce. Okay, let's do a T dot right and go 120 degrees and draw another triangle. T dot right 120 degrees, draw another triangle. Let's see what that does. I'm not totally sure what the triangles are going to look like. That's kind of cool. It would be neater if it was positioned vertically or, or horizontally. I need to redo that. So right now, what it's doing is I need to increase the speed.
Your speed's faster than
More speed. All right. But I want it to start drawing that way rather than up, so I need to turn 1 more degree. There's another way you can change your heading. I'm going to give it a shot and see if this works. T dot heading, and I want it to go 0. Unfortunately, that just returns a heading. Let's see if set heading works. If at first you don't succeed, you Google.
You're not wrong.
Turtle, Python, set heading.
I can't tell. Hello, little turtles. Man, you just messed this whole thing up.
I don't want to return the heading. I want to change this heading. Set heading. Alrighty. Okay. So here I'm going to do set heading and get him going back to his original direction. So no matter what the angle is. And in turtles, 0 degrees is off to the right rather than straight up as humans consider it. Turtles are confused. Yeah, there we go. Still not a triforce, but it's like a nuclear radiation symbol. I guess that's cool enough. Okay. So the real point of this was to show encapsulation. Let's take all of the window drawing and just call that draw window. So above it all, I'll be right back there. Do DEF draw underscore window colon and then tab everything down to that set heading. Just leave that set heading alone. Heck, make set heading part of it. Tab that one too. Do the same thing with draw try. Excuse me. With the triangles. What am I going to call that? Draw underscore 3 try? Yeah. Define space draw 3 try. Colon. And then tab all that stuff over. The reason it doesn't draw anything is because it's all functions. It's no code. You know, drawing up functions is like writing a plan. You've written a plan, but nobody's doing it. So we just have to go down to the bottom and call our new functions. Go down to the bottom and add draw underscore window, and then do draw underscore 3 try. Alrighty. So that's about enough of that. Let's go back to our how to think like a computer scientist. No, there was something more in our faux PowerPoint I wanted to look at. This is considered a typical pattern of programming. Now the term pattern actually comes to mean something much more specific later. But when you're writing a program, very often you define your variables up at the top. Then you do what's known as housekeeping. Like if you have to open a file to save your results to, or if you have to open a database to read from, you're going to do all that. So you declare your variables, you set stuff up, then you do the housekeeping, opening files or whatever, and then you enter a loop. You're not at the end of the file, do something. You're not at the end of the file, do something. Now that's not how I draw a while loop, but that's how they do it. And then once it's finally done looping, you do the stuff that you have to do at the end of the job, like close all the files. So maybe this one opens a file to read from. That's the housekeeping. Then it does that, and then it closes the file. I would have called that more housekeeping or something. I mean, you're setting up your party here, you have your party here, and then you clean up after it once everybody goes home. So a lot of tasks follow the 3-module format just described. For example, a candy factory opens in the morning and the machines are started and filled with ingredients. That's the housekeeping. We fill up our giant vats with sugar, and then the candy is manufactured. So there's something going on over and over and over until we get tired of making candy. Then the machines are cleaned and shut down, and we put the candy on the truck to ship it off. And so that's the stuff that we do at the end of the job. You're going to drive somewhere. You start your car. You keep driving until you get there, you stop the car. Very general process, but that's actually what we did. Ours looks a little bit more complicated because it's got more than one loop and stuff like that. But it's the same idea. Here is our setup, our housekeeping. Part of our housekeeping was opening a new turtle, creating a new turtle. Then we had to scroll past all the modules to get to the first unindented stuff. And the unindented stuff was the code that actually did the useful work, like making the candy. So then it ran up here to draw a window, and it called draw square several times, you know. So we had some looping involved. Computers are all about the loops. Then It was done drawing the window, so it returned, which ran it back down to 3 try, or that statement was done, so now it was ready to do that one. It came back up here and ran those statements, each one of these invoking draw try, which runs it up here to do the loop. So really, how many sides did we draw when we drew our window? We didn't just draw 4. How many rectangles how many squares did we draw? Yeah, so we drew 16 different sides. And to do our try symbol, our radiation symbol, we drew 9 sides. So via the magic of looping, this code was executed an awful lot. These few lines here were executed 16 times in a row, even though we couldn't have guessed that just by looking at it. And this code was executed 9 times in a row. That is an example of modularizing. This one didn't have any cleanup, you know. We didn't have to clean up our party. So there wasn't, if we followed this pattern, end of job, there was nothing to do there. What you might want to do on your normal type of programs is add a final input statement that says press return. Don't do it for this one. But you know, if you double click on a PY script in a folder, it usually runs it, and then it closes the window before you get to see the results. This would stop it from doing that. Alrighty, let's modularize some kind of mathematical calculation, and I'm not coming up with a real good one. We've already done interest already, but we can come up with something. Let's do new file, and we're going to write a module called calc_awesome. We're going to figure out our awesomeness. Define DEF calculate awesome. And how we calculate our awesomeness is our age times our GPA. You know, this is stupid, but whatever. So then we're going to do is equal to age times GPA, and we're going to return it. Return Now let's write 2 more modules, one called getAge and one called getGPA. So DEF get_age. We're not passing in any data to this one, so we don't need anything between the parentheses. And just like whenever we were converting pseudocode, we had to do the 3-step input. Print, what is your age? We needed an input. Age is equal to input, and we need to convert it. What's our conversion step? Let's make it a float.
Age equals float, parentheses, age.
Yep, age is equal to float, parentheses, age. And then let's return it so that the other program can use it. Why? Because age is local to this function. I couldn't use it anywhere else unless I return it. Here is local to this function. I couldn't use it anywhere else unless I returned it. All right, we want to do the same thing for GPA. Write a similar function, something similar to getAge that does getGPA. I'm going to just chill out for a second and let y'all work on typing that. Yeah, it doesn't run yet, but we're getting there. So print, parentheses, quote, what is your GPA? Then GPA is equal to input, parentheses, in parentheses. GPA is equal to float, parentheses, GPA. Now we're ready. Right now it doesn't do anything, just like the other program. Why? Because everything is indented. We've created a bunch of plans, but we haven't given them to anybody to execute. we made a blueprint, but we didn't hand it to the contractor to build a house. I'm just going to call this one awesome. I'm going to be so disappointed later when I wonder what awesome.py is and I open it and it's just this. Okay, so here we go. Let's calculate, or let's ask for the age. Age is equal to get underscore age. GPA is equal to get underscore GPA. Now we're going to call this function calc awesome, and we're going to pass those values into it. Aw is equal to calc underscore awesome, and let's pass in age and GPA. And now we're going to print. Your awesomeness is, colon, quote, comma, ah. What is your age? I'm going to lie and say I'm 18. What is your GPA? Well, I'm making a 2.5. And it blew up. I did something wrong. I forgot to return GPA. I bet y'all who wrote these functions yourself before I typed it did so. But get GPA doesn't end in a return GPA, so I need to tack that line on. Return GPA. I had to add that line. Alright, I'm older and wiser now. My age is 25. I'm making a 3.7. It says my awesomeness is 92.5. Cool.
Thought I was pretty awesome.
Alrighty, the next step would be to flowchart this. I'm trying to figure it out if we could do that in 10 minutes. I'm kind of thinking not.
I don't think so.
You got a question back there, sir?
I got a question. Then we certainly are not going to skip to the flowcharting.